Hi, welcome to the G Research Open Source Software Outreach Podcast, the Gross Out Podcast, where we gross you out with the details of how real open source is done. And we're here today with Jonathan, who's going to talk to us a little bit about FasttrackML. Jonathan, why don't you introduce yourself, tell us your name, and what exactly you do?
Hi, I'm Jonathan Giannuzzi. I'm an open source evangelist at G Research. I'm helping out the people at G Research with adopting open source software, with making contributions to it, to let it evolve, and all kinds of stuff like that.
So like evangelist implies like sort of a directionality, right? Like you're trying to like evangelize someone. Is that sort of job pointed internally or externally with that sort of thing? Are you often like evangelizing open source to the people at G Research or evangelizing on behalf of the people at G Research?
So it's actually twofold. I these days I've done more in-reach than outreach, but now I'm doing more outreach thanks to this podcast. But it's been a lot of it has been like about convincing people, hey, when there's this proprietary solution, you should also look at this open source alternative and also consider all the engineering muscle that we have to help this open source project thrive and be really useful for you. But it is also about the outreach, yes.
So in your job as a open source evangelist at G Research, are there particular projects that you focus on or that get a lot of extra care and feeding from you?
Yeah, so lately I've been involved with FasttrackML, which is a project I started a bit more than a year ago. And so that has consumed a lot of my time. But then it can be also very varied. And, I've contributed to things like .NET or Docker or FasttrackML more recently. It's very varied.
So I think there's maybe a perception sometimes that people who do developer relations or like developer evangelism are not necessarily highly technical. Like, can you help me debunk that a little bit? Because it sounds like you've got changes in a lot of places. Like, I'm assuming that's a little bit more than just a documentation update. So, like, is there one of those we can talk about a little bit?
Yeah, totally. When I started FasttrackML, I didn't start with documentation. I started with actual code. It actually started as a project where it was just code and nothing more, very bare bones that people started to use inside. And then it grew up into an actual project that we've open sourced. But if I just take the contribution to .NET that I was talking about earlier, that was actually fixing a really gnarly bug that prevented .NET from running in macOS Apple Silicon virtual machines because of memory protection. So yeah, you can do DevRel and be extremely technical.
That sounds really interesting, and I could probably spend the whole podcast talking to you about technical details of that bug because it sounds really neat and a little bit near and dear to my heart with like the hardware issues. But we're gonna steer into what's a little more unknown territory for me because I mean I'm a cloud guy. I work on cloud provisioning and stuff like that. I've not been an AR and ML person, and I know that that's sort of core to a lot of what G Research does and to a lot of what Gross does. But that's me admitting a little gross detail from Jay is that I'm not an AI or an ML person. So like let's maybe not start with FasttrackML. Let's start before that. Like what were sort of the problems in the AI and the ML space that existed that sort of spoke to you that made you want to create FasttrackML? Can you maybe give me explain it to me like I'm a 5-year-old about AI and ML so that we can get to that problem and talk about how FasttrackML solves it?
Yeah, sure. I'll ask you to be more like 15 for this one because 5 years old is way too early.
I don't think I can manage that level of petulance. So,
so I'll start by giving a little bit of context so that I can even explain what the problem space is. So the first thing you would need to know is like, what's kind of your usual workflow when you do machine learning, and what do we mean by machine learning? So super briefly, you have those things called models. You must have heard about that. And those models are, you feed them some data and then they give you some data out. Like you feed them some pixels of an image, and then they tell you, oh, it's this text that's written on it, for example. And in order to get there, you need to train that model. And training that model essentially means that you're going to create some architecture, and that could be a neural network, a tree, all kinds of things. And kind of, I can't explain that part to you like you're 5. So just bear with me. You've got an architecture, and then this architecture needs to have, it's got a bunch of knobs all over the place. We call that parameters or weights and biases. And so what you want to do when you train your model is just find what are the best values for all of those knobs. Like, how should I turn each of them? And, you've probably heard about those LLMs that have billions of parameters. That's what we're talking about. So the model is this architecture, and then all those values for the parameters. And when you're training your model, what you do is that you take a data set, which is, it's kind of like flashcards or things like that. You've got a bunch of questions and their answers. You've got a bunch of pictures and maybe the text that's on the picture or the description of the picture, things like that.
So
and you're
with
going
a
to,
model,
yeah, go ahead.
just to have I just want to clarify, make sure I got the boxes drawn correctly. With a model, is that something that's generic? Like, can I take a model and train it with 5, or can I take a given data set and use it to train a model 5 different ways and get 5 different functions out of it? Or are models going to end up being, or like, is that training process going to always give you a model that's sort of the same thing? Like, how generic is this? Is it, you can train this with pictures of puppies and tell them which ones are puppies and not puppies, or you can go completely a different direction and do more LLM style querying, or is it, do each of them kind of have a box or an alley that they stay in?
So these architectures get really complex, but short answer is you will need a specific kind of architecture for a specific kind of problem. And maybe if we've got any ML researchers listening to this podcast, is going to be going to just like grab their head into their hands. Be like, no, but let's simplify all of that. You basically will choose certain things. You'll have like something called a transformer if you want to do something like an LLM. And when you do vision, you're going to do different kinds of stuff. Like there's loads of different architecture, and that's kind of like, that's the job of the ML researcher, to think about which architecture will be better for the function, for what you're trying to solve.
So is the output for an ML researcher like a software that trains the model, or is the ML, or is like usually an AI researcher actually targeting the model itself, like the trained thing is the endpoint? Because as a software developer, I'm used to being like a step removed, right? I write software that people use to provision clouds. I don't provision a lot of clouds in my daily job. How does that work? Where's that line with between like an AI ML researcher and maybe like a user? Or is there a line?
Yeah, I'd say, well, my understanding of the line would be that the output is the model. So it's that code describing the architecture, which you will use some framework. Many of them are, you must have heard of PyTorch or TensorFlow. So those are frameworks for that. You will describe your architecture in some code with one of those framework, and then all of those parameters, the model weights. So that big thing. If you take an LLM today, you will sometimes download something like llama.cpp, which is an implementation of the architecture. And then you will need to download the weights, which are going to be gigabytes of data. And the output is the combination of those two. So the ML researcher, the output of their work is going to be that. What happens with that after is something else.
So I'm going to make the AI researchers angry here now by restating it in too simple of terms. So that's why I'll protect you. Like, it sounds like what you're describing to me is someone who's a Python developer as like you've got a basic like meta class written, and that you would like class that to make your own special little things, but you're mostly using machinery that has been given to you. But that's not the endpoint. That's almost like code generation. And then you run that And that would be like running your data against your training set, and it generates a piece of code at the end that you're actually delivering. So like when I go in and use something like a chat GPT, I'm actually interacting with a model that someone created that I'm like 2 or 3 steps removed from the actual training process and the data itself. This has been so helpful for me personally in understanding this, because the fact that the data kind of doesn't flow in one direction and flow out the other. It's like a multi-step process when a lot of times you don't have as many of those steps in traditional software development. That was very useful. Many people have tried to explain AI and ML to me. You're the first person to get any of it to stick. So I appreciate that, Jonathan.
Happy to help.
And now that you've solved the J problem, I'm curious what problems that FasttrackML solves. So like where does FasttrackML fit into these architectures, and what sort of problems is it trying to solve?
So, well, the thing is that in order to get there, you'll need to train your model. And the training is the process of finding the best values for the knobs, right? And the way you're going to do that is that you're going to have your data set, which is, those questions and answers. You're going to split that into training data set and validation data set. Basically, that's a way to make sure the model does not know all the answers and has just memorized them. But then you'll be able to use that testing data set to check whether your trained model gives the good answers to questions where it doesn't know the answer. And the way you're going to train it is that you're going to do, and I'll try to simplify that because otherwise this podcast will never end. But the way you're going to train it is that you're going to choose, you're going to let your model with some randomly chosen knobs to begin with. And with that little architecture, you're going to feed it the questions, look at the answers. Probably going to be wrong. And then you're going to determine how good or how wrong the answers are. There's all kinds of mathematical formulas to get there. But in the end, you kind of want to have numbers that express model did a good job or model did a bad job. And then you will want to say, okay, in order for the model to do a better job, what knobs should I change? Again, in order to do that, all kinds of mathematical formulas and whatever. But you're going to now change some of those knobs, and you're going to iterate. You're going to do the same thing again. Feed it the questions. Look at the answers it gave you. And hopefully it's better. If it's not better, you probably just at some point in time you will give up. But you will iterate like that. Just keep on turning all those little knobs until you find the right knobs. That's the training.
It's actually like this is a revelation for me, because for someone outside of that ecosystem, when you hear data scientist, it sort of sounds like when someone calls themselves an influencer, where you just sort of want to raise an eyebrow and be a little bit skeptical. It's like, you're a scientist, you say. But this sounds cool, because what you've described is the scientific method. They set up an experimental apparatus. They have a hypothesis, they test it, they evaluate how correct it is, and revise it. This is the scientific method come to coding, which all of a sudden everything makes a little bit more sense as to how it seems like answering questions like, is this correct, all of a sudden turns from yes or no to a little maybe, because that's kind of the nature of science. This is a revelation to me. That's pretty neat to hear. So how does Fast Track fit into that training process?
Well, that's the next step. Is that would be good if you could just do that. But the thing is that you actually have some other knobs that are above those knobs I was telling you about. Because how do you determine which knobs you're going to turn? How do you determine how accurate the thing is? How do you determine in which way you're going to start with your random knobs at the beginning? How do you determine certain parts of your architecture, like you've got multiple layers of neurons, but actually for this layer, if I've got 20 instead of 25, maybe my thing will behave better. And this is what we call hyperparameters. It's yet another bunch of knobs. Those knobs, when you change them at the beginning of a run, at the beginning of a set of iterations, this is where FasttrackML comes in. because a researcher typically will want to create multiple runs where they start with different hyperparameters. And then they will do a few iterations. Mind you, doing iterations is quite costly. Like if you've got a very complex model, and we do, and you've got many parameters, and we do, then you end up having to need you need multiple GPUs, which, by the way, we can very easily provision thanks to Ironic.
So it sounds like FasttrackML is sort of helping you multiply out the matrix to get it run, but I suspect you're about to tell me it's going to save me a bunch of GPU power, perhaps?
Not exactly, not directly, but would be nice if it could. So it doesn't come out into that space. So you've got all of those frameworks that do those things for you, and there's constant innovation there. But the thing is that you need to have those multiple runs, and you don't want to run to iterate for a long time if it's not going anywhere. But what you want to do is you want to build intuition between those hyperparameter knobs that you're touching at the beginning and how well your model is doing over the course of iterations, how fast it's learning, if you will, how well it's learning. And so that part, in order to visualize that, this is where FasttrackML comes in. Because, many researchers till to this day, they use like sticks and stones in order to do that. They will maybe track that in some Excel spreadsheets. Or maybe they will just try to dump that as CSV files or JSON files, and then they will go into their Python notebook and try to build another data frame out of that and do some charts and everything. That's tedious. And it's also not very universal, because you can have multiple researchers in the same team that maybe use a different way to do that. And so they can't really share their results with one another. And so the tools that I use to solve that I call ML experiment trackers. So it's a thing that's going to allow you to log your metrics, to log how well your model is behaving over time, and the hyperparameters that you started with, and then be able, with all of that together, to visualize it in nice charts that are laid out, and to be able to explore all of that and see which run performed well and all of that.
That's the thing I think is actually kind of a universal problem across tech, though, in a lot of ways, is that one of the more difficult things to do is communicate how well or how badly something that you're doing is working, especially when it's not a Boolean pass-fail sort of scenario where you're just trying to get to that point of good enough. That sounds like it's a really useful tool. Do we have any... do we have like a demonstration or anything we can do to show? I know that a lot of people are going to be consuming this over audio, but is there something, maybe we can talk about how it looks or show a demo or something of that nature?
Yeah, I kind of don't want to show a demo, but people can go to FasttrackML.io, and there's a couple of screenshots there. And actually, if they're interested, they can just go to our quick start, which is really dead easy. We support all kinds of things, whether you're using already Python and you want to pip install the thing, or you're using Docker, or even if you're one of those people that likes to curl something out of the wild internet and pipe it into your shell, we support all of those methods of installation, and should be up and running in no time. And then you can actually just exploit for yourself and see what the UI looks like. But, talking about the UI, this is actually a key point. So the reason we started FasttrackML is kind of an accident. There are already tools that exist for that. And one of them that is really popular is called MLflow. It's a really, really good. It's a really, really good experiment tracker. It does more than just experiment tracking. There's also other, and it's open source. There's other projects like AIM, or there's also another one called Weights and Biases, which is not open source. All really good tools. The thing is that all researchers, there was an effort to say, hey, let's stop with the sticks and stones. Let's try and find one of those tools. Let's evaluate them and let's use the best one. So we started to look at that. And MLflow, what's fantastic about it is that it's got great ecosystem support. So what that means is that if you're using PyTorch, TensorFlow, or some other maybe less popular machine learning framework, you're going to be able to integrate with MLflow with just like one line of code, which is super good when you're trying to get people to adopt those tools and to use a better method. However, the UI is not fantastic. And the other thing that we found with MLflow is that with the amount of data that we are throwing at it, so when I say we, I mean G Research or researchers, it didn't scale. It just was performing very poorly. We also looked at AIM, and AIM has a really good intuitive UI. So that's something that's like super invaluable because it really helps anyone just quickly adopt it and quickly look at their charts and everything. But AIM didn't scale either, and then it doesn't have the same kind of ecosystem support. Then you've got other tools like weights and biases. It's proprietary. You get locked in. Like, this is an open source podcast. I'm an open source evangelist. I'm not a huge fan of that, but it's a good product. However, you can't customize it. And we have some special needs. Like, there are certain things where we like to, we're big on time series and things like that. If you have a proprietary product, you're completely dependent on your provider to have any kind of changes. And if they don't want to do it for whatever reason, you're not paying them enough, you're too small, or they don't have the resources, you're not going to get it. And then we had like a fourth option, which is like try to evolve one of our sticks and stones into something better. But those were the options we were presented with. What we decided to do is that we looked at MLflow, thought it had all the good properties apart from that scaling thing. And I just looked at it and I was like, okay, why is it slow? And Jay, you may have done something different from what I did. But I looked at it and I was like, oh, it's written in Python. It needs Unicorn and this, and it's using SQL Alchemy, which is an ORM, which is not super fast. It's all very nice and the code's very clean, but it's very hard to make it scale to the amount of data we had. It's not unsolvable.
Picking a tool is pretty important. I mean, those are all tools that I use in Ironic, but with Ironic, we also have to wait 10 minutes for servers to power on sometimes. We don't have a bunch of data scientists pumping data in. So like it makes perfect sense to maybe try to switch languages because it seems like based on where it is in the pipeline, it's doing a lot of like data processing type of activities, which Python's not really the greatest at in terms of speed.
Yeah, exactly. And so, I looked at it, I was like, oh, maybe if we use async, and then maybe if we use things like twisted, and maybe if instead of SQL Alchemy, we do the SQL directly. Like, wait a minute. This is rewriting the whole thing. If I'm going to have to rewrite it, then I might just look at what I think is a good tool for the job, and it's not the only tool. But I know Go. I was like, Go scales easily. It's got good support for stuff like talking to databases and serving JSON as a web server. Just try it. And so in like a week or something, I had a little prototype where I implemented the MLflow API with the same data model, and it was working.
Yeah.
And it was, depending on what you were doing, between 2 times to 100 times faster.
Yeah.
And it was just like dumb code at that time. Like it's just the most naive implementation I could do. So I was like, okay, maybe I'm onto something here. Then I made the mistake of letting the researchers know that I had done that and showing them. They're like, we want to use it now. But my code is not ready. No, but it's good. It works. We want to use it now. So gave it to them. They started to use it. found some bugs, fixed them, etc., it grew from a proof of concept to something that they actually used. And so from that point on, we were like, okay, what do we do with this? Do we keep that to ourselves? And then just no one benefits from it. And then we just, stuff keeps evolving outside. And then at some point in time, we've diverged completely from the state of the art and we need to change to something else. Or do we actually just contribute that to the world and make it so that anyone can use it, anyone can contribute, and we hope it reaches and develops into a nice blooming community, and then other people can help us, and all the good open source stuff. So we decided to open source it.
How successful has that been so far? Have you had a lot of interest from other companies in contributing or using FasttrackML yet?
So far we have not had contributors yet, but as I like to say, like, you need to have a lot of users before you start to get any contributors. On top of that, the users that are interested in a tool like that are not the kind of people that build tools like that. Like the Venn diagram between users and people that can develop that is very thin.
Is the shape of a developer evangelist? That little Venn diagram, it's a little Jonathan shaped combination in the middle there.
Hopefully there's more than me.
Well, I mean, I think actually it takes a special word. Like, that is one of like the things that I would point out as like a gross thing in open source that people don't like to often pay attention to, but there is a niche there for people. You provide an example. I think I do this a little bit in the OpenStack community, of where you're sort of standing in that middle spot between some of the users and some of the people who are working on it, and trying to translate, trying to make sure that people are communicating. And that can be extremely difficult, especially if, like, you're working on a piece of software that straddles that. So is there if there's someone listening to this podcast right now, they searched up FasttrackML, found us on YouTube or through one of the podcast apps, and they're saying, I'm having these problems, I'm having speed issues with MLflow, what would you tell them to do for implementing FasttrackML? Is it just going to drop right in?
So it is pretty much that. We've got a little migration guide because our data model has diverged from MLflow. The main reason is that we've added a new UI. So, by implementing just the backend bits, I was able to just take the UI from MLflow and just serve it on top. But then our researcher was like, hey, that AIM thing you showed us, like, could we get that UI as well? Well, why not? If I implement the right API endpoints, I can just take that UI and put it there. Just full disclosure, both of those projects are Apache licensed, and we are Apache licensed as well. So we're cool, we're clear. And we talk with both of them. It's not a ripoff. But like, yeah, we can graft that UI on top. So we've grafted it on top. But the thing is that AIM has some different concepts from MLflow in certain places, etc. So you end up with we had to evolve the data model. So in a nutshell, if today you don't need to keep any of your data and you just want to run whatever you were already running that was logging to MLflow to FasttrackML, it's a drop-in replacement. If you want to take your existing MLflow data, all the stuff you've logged in the past, but be able to look at it faster and with nicer charts, and log your new stuff, then we've got a little guide to migrate your MLflow database into the FasttrackML database. All of that is on our GitHub repo.
All right. Well, that sounds wonderful. So that's actually pretty neat. I'll go look at the demo after we're done here. The one thing that we always like to end the show with is, the concept here. We've got the name is gross, and that's an acronym and all that. But part of the reason we have this podcast is that, a lot of people like to go out on social media and like show the best face. You show the happy paths, the happy stuff, but we live in the real world. The real world's not always happy. Sometimes the details are a little bit gross in terms of how we get from here to there. So with sort of this journey you've laid out for us over, the whole path of AI and ML, is there a spot where you've hit like a really gross pattern where you've had to solve it in maybe a less than ideal way, or struggled a little bit? Just sort of let our viewers know the unvarnished truth about what happened.
The answer is yes. Yes. There's that has happened many times, but I'll just pick one. So, we're dealing with FasttrackML, we're dealing with databases, right? And what we support in FasttrackML, we just picked the two most popular things we could think of. One is SQLite, which is that embedded SQL engine. It's great because it allows someone to just start using FasttrackML immediately. Don't need to do some kind of complex deployment or whatever. Not fit for production. Not fit for production. And then you've got Postgres that we support as well. It's a great database. Everyone loves it, or at least I love it. Fantastic, awesome, genius. The thing to know about SQLite is that when you've got your database schema and you want to make changes to it, like, I don't know, you want to change a column from not null to null, or just almost any kind of schema change, what you'll need to do is that you will need to create a new table with that new schema. And then you'll need to just migrate all of your data to it, and then remove that first table and rename and everything, which is just so gross. What happened to us is that we've been doing a bunch of migrations, like with almost every release, because we introduced new features and everything. There's some database migrations. And we use an ORM to do all of that. And all that is fine. And then with SQLite, you've got this terrible, terrible recreation of the schema. It's fine. People inside that are using FasttrackML use Postgres. Anyone listening to this that wants to use Postgres in production, use Postgres, please. All of that is fine. However, our ORM did not manage some special thing, so we had to write some SQL for it. Then we bumped into the fantastic SQLite recreate your schema stuff. So we made some code for that. We shipped it. People inside were upgrading to the latest version of FastTrack. And then they asked us, hey, this migration's been running for a while. Is that normal? What is a while? What? 10 minutes? Okay, well, you've got loads of data. Maybe that's normal. Let it run. Then an hour later, hey, it's still running. Is that normal? Oh, that's definitely not normal. Okay, kill it. Then, of course, you run into all kinds of problems. You can roll back the transaction, but in the meantime, something deadlocked in the database. We had to call the admins to stop it, etc. Data was safe in the end. But what we learned is that we had a piece of code where even for Postgres, even for the billions of rows that our researchers have, we were doing this whole table recreation dance. And so what we've done now is that we've got something running daily in our CI that is just checking all of our migrations against a really big database and checking that it's not going over a certain amount of time that is our baseline, so that we will never, ever ship again a super slow migration to anyone.
I'm sitting here just imagining that DBA with why is all the disk space on my Postgres DB all of a sudden disappearing? And the massive vacuum that had to have followed that would be great. But yeah. I agree. SQLite is a really great tool. Can have significant challenges in production. We dodge that in Ironic by supporting SQLite but not upgrades. So if you want to keep your data, you have to pick another database. So you're braver than we are for tackling that migration. But so, Jonathan, before we let you go, do you have anything here you'd like to specifically talk about? We're obviously going to point people at FasttrackML.io so that they can get information on how to use FasttrackML, contribute if it's something they're very interested in. But do you have any socials, anything you'd like to share before we let everyone go?
Well, I'd like to share just one thing, which is that in the spirit of open source, we've been in touch with the MLflow maintainers, and we've asked them whether they would be interested in us taking some of the IDs that we've brought into FasttrackML and upstreaming them into MLflow, so that we can open that to a wider community. Of course, you won't get the new UI and all of those things, but the core principle of performance, scaling, etc. And so we're going to start an effort to upstream that into MLflow, so that there's even more users that can just reach and that can have that goodness.
That open source osmosis, that is the reason I like open source a lot, is there's so many situations where just by having a conversation, you can influence another project or another person in a direction. That sort of, not just the pushing side of it, but that attitude as well. Like having been on the other side of that, where someone came up and said, "Hey, we did a cool thing here. Would you like a piece of it?" It's very nice, and that is the very not gross thing of open source to end the podcast on. But that's fine. Thank you very much for your time, Jonathan. Thank you to those listening. This is the G Research Open Source Software Outreach Podcast, grossing you out, and we'll see you next time. Thank you.
Thank you.